Section 5.2 is titled Structure of the Atom. We're going to start by summarizing our findings from Section 5.1. We've determined that atoms are made up of subatomic particles. Sub meaning smaller than, atomic meaning the atom. So we've defined 3 subatomic particles: electrons, protons, and neutrons. We've described them in terms of their location, their charge, and their relative mass. We use the term relative mass because we are comparing the mass of these subatomic particles to the mass of the other subatomic particles. Let's start with the first subatomic particle, the electron. We say that the electron is found traveling in orbits or energy levels around the nucleus. And we say that they are negatively charged, and we give them a mass of approximately 1. The second subatomic particle that was discovered was the proton. And we said that this proton was located inside the nucleus and has a positive charge. And if the electron is given a mass of 1, then the mass of the proton is approximately 1,836 times more massive than the electron. So it's almost 2,000 times bigger than the electron. The third subatomic particle is also located in the nucleus. We said it has no charge, therefore it's neutral. And it too weighs almost exactly as much as the proton and almost 2,000 times more than the electron. So if you take a look at the subatomic particles that make up an atom, we can see that most of its mass comes from the protons and the neutrons, and therefore most of its mass is found in the nucleus of the atom. Now we started to take a look at the periodic table, and we saw that the periodic table is filled with symbols, and those symbols represent elements. We asked you to remember the first 20, the ones that were numbered 1 through 20. So hydrogen is number 1, helium is number 2, lithium is number 3. Well, that number that is associated with those elements on the periodic table is called the atomic number. And that number gives us some important information. The atomic number tells us the number of protons in the nucleus of an atom. So for example, if hydrogen has an atomic number of 1, then that tells us that hydrogen has 1 proton in its nucleus. If helium has an atomic number of 2, that tells us that helium has 2 protons in its nucleus. Take a look at your periodic table. Take a look at the elements that are listed. I want you to identify the atomic number. And there's a legend at the top of your periodic table. And this legend right here shows us where the atomic number would be located on this periodic table. So for example, titanium has an atomic number of 22. Now there's also another important number that's associated with each of these elements on the periodic table that you're going to be required to know, and that is the atomic mass. So if you take a look at the atomic mass of titanium is 47.9. And most of the atomic masses on the periodic table are expressed in a decimal, with a decimal. So this is 47.9. For simplicity and for ease of studying this information, we're going to always round the atomic mass to the nearest whole number. So 47.9, if you were to record the atomic mass of titanium, rounding it to the nearest whole number, what would we say the atomic number or the atomic mass of titanium is? AJ?
48.
48. Perfect. So we can locate the atomic number and the atomic mass for any one of these elements on the periodic table. What does the atomic mass tell us? Well, the atomic mass is also known as the mass number. And it tells us the sum of the number of protons and the number of neutrons in the nucleus of an atom. So this tells us the total number of protons and neutrons in the nucleus of an atom. So here I have the chemical symbol for boron. There are two numbers here, number 5 and number 11. One of them is the atomic number, and one of them is the atomic mass, or mass number. How do I know which one is which? Well, there are two clues. First of all, you've studied the first 20, and you know the song that will allow you to determine the order of these. Well, the order is equal to the atomic number. So if you remember what the fifth element is, it should be boron. In general, you can state that if there are two numbers associated with them, the smaller number is the atomic number. So the smaller number here, number 5, is the atomic number. And the larger number is the mass number. So you can remember that the bigger number or the heavier number is the mass number. So from the periodic table, with the atomic number and the mass number, you can calculate the number of subatomic particles present in one atom of each of the elements on the periodic table. So how do we do this? Well, how do we find the number of protons? The number of protons is equal to the atomic number. So if you know the atomic number, you know the number of protons. Next, the number of electrons. How do I know the number of electrons? Well, if you know the number of protons, the number of electrons is equal to the number of protons in a neutral atom. So atomic number gives you protons, and if you know protons, then you know electrons. The last subatomic particle that we're responsible for is the number of neutrons. How do I find the number of neutrons? Well, I know that the mass number tells us how many neutrons and protons are in the nucleus. So the mass number is neutrons and protons, and the atomic number is just protons. If I subtract the mass number and the atomic number, what I'll be left with is just the number of neutrons. So you take the mass number, subtract from it the atomic number, and you get the number of neutrons. So let's take a look at boron. And we said boron has a mass number of 11 and an atomic number of 5. So the number of protons and I'm going to use the symbol P plus to represent protons. We said the number of protons is equal to the atomic number. So how many protons does boron have? Kazari. Perfect. Number of electrons. I'll use the symbol E with a negative sign to represent the number of electrons. If I know the number of protons, then I can write down the number of electrons. And in a neutral atom, these are always the same. So how many electrons do we have, Adrian?
5.
The last subatomic particle is the neutron. In order to do so, we have to subtract the atomic number from the mass number. Whenever you're doing this, I want you to write out the expression. Don't attempt to do this in your head. Take the time and care to write this down so you don't make any simple mistakes. The number of neutrons is equal to 11 minus 5, which is? Nader?
6.
Perfect. So I'm just going to write a therefore statement expressing our findings. Therefore, an atom of boron has 5 protons, 5 electrons, and 6 neutrons. We're going to take a random element. This is element with atomic number 30. Atomic number 30 is outside of the first 20 elements that you're required to know. So you don't know what this element is or anything about it. But from the periodic table, you can see that the atomic number is 30. And the mass number is 65. So from this information, we can determine the number of protons, the number of electrons, and the number of neutrons present in one atom of the element zinc. So, to determine the number of protons, I look at the atomic number. How many protons in one atom of zinc? 30. Mackenzie, how many electrons in one atom of zinc? The number of electrons is equal to the number of protons, therefore it will be 30 as well. Now, the number of neutrons is found by subtracting the atomic number from the mass number. So giving me the mathematical expression and the answer, Aaron? Perfect. 65 minus 30 equals 35. So in one atom of zinc, there are 30 protons, 30 electrons, and 35 neutrons.